Howdy, chemsters. It's Bowles here, talking about moles. Mrs. Bowles talking about moles. That's kind of fun. Here's how it goes. So a mole, my friends, has to do with chemistry. It's a really important number in chemistry. It's the number I have on the back wall of my classroom that some of you have been asking about. It is what we call Avogadro's number. And just to be real simple, a mole is just a way to count atoms as a chemist. And it allows us to do some calculations that are really important in chemistry. So let's just go back to something we already know about. We already know about atomic mass. And if you remember, what unit, think back, is used for atomic mass? It's called the AMU, an atomic mass unit. So when we say C-12 or carbon 12, it has atomic mass units of 12. That means its total mass, protons and neutrons, must equal 12. Okay? And the periodic table gives you those numbers. We also call it relative atomic mass. So how many AMUs are in O-16? Oxygen, 16. 16. How many for copper 63? 63. So the AMUs are basically the atomic mass units that each atom has from the periodic table. Now, if you kind of want to understand the concept a little bit more, let's think about something you're familiar with, like eggs. When you buy eggs in the store, how do you buy them? You buy them in dozens, right? When you go to the store, you can't just take one egg to the checkout and try to buy it. They come in a carton called a dozen. What about shoes? How many shoes do you get in a box? A pair, right? 2. Everybody knows that. You buy 2. And that's called a pair of shoes. Well, in atoms, all you need in atoms to talk about the carton and the way they're packaged is something called a mole. 6.022 times 10 to the 23rd atoms. Quite a lot. We don't even have a number to explain that that's simple for us. It's called Avogadro's number. It's how many particles are in this quantity, like a carton, that we call 1 mole. Okay? And the mole concept allows scientists, chemists, to count atoms. Because atoms are so small, they fit into your hand. So in reality, how do you count them? You use this number that was discussed and given to us by a scientist by the name of Amedeo Avogadro. This is his name, pretty long. He was Italian, was an Italian physicist, and he was doing experiments, and he came up with this law that said equal volumes of gases under the same conditions will exert the same temperature and pressure, and what he found out is that they have an equal number of molecules. And that number, after his death, he never knew he had a number, is become known as Avogadro's number. And that's how many particles in every mole of every substance. So what does that do for us? Well, there's a few definitions you need to understand. The number of carbon atoms in exactly 12 grams of carbon-12, that's the definition for a mole. And when you're getting ready to convert from moles to grams and grams to moles, because, by the way, those AMUs from the periodic table, we also equate those to grams. So, 1 atomic mass unit is also called the molar mass of an element, and we looked that up on the periodic table. So that is how many grams in 1 mole of that element. So for carbon, it's 12 grams when we look up the relative atomic mass. For sodium, it's 22.99 grams per mole for every mole of it. For oxygen, 16.00 grams in every mole of it. So when you get ready to do some problems, which we're going to start on today, you can convert from grams to moles and moles to grams and even to particles and atoms. So just to start a simple problem, we're going to do like we always do with our picket fence. We're going to put the given on the upper left. Sorry about that, Belle. Given on the upper left. And then we do just like we did before, and we're going to make those units match. So the units here are going to match, and the units of what we're looking for are going to match. So we need to solve for moles here. So here's what we do. We find the molar mass from the periodic table, and we're going to set up a conversion factor. The conversion factor is going to have grams on the bottom to cancel and moles on the top. Why? Because we want to solve for moles over here. We want to solve for moles. So what we're going to end up doing, math-wise, is we're going to end up multiplying straight across and dividing what's on the bottom. So you're going to have 12.3 divided by 4, or 3.08 moles to solve this. So keep in mind while you're doing these problems that your conversion factors are either going to be the molar mass over the mole, or the mole over the molar mass. You can flip these back and forth. So for carbon, that would mean you could use carbon's mass of 12 grams in 1 mole, or 1 mole in 12 grams. How do you set it up? It all depends on what your given is. Let's try